We are going to see the how to simulate scissor lift table using Adams view. So you can see the how it is getting simulated. So let's first start. So this is a CAD model of lifting table. You need to save in the parasolid format. If you go in the save as, so you can save here as a parasolid. So already I have saved it in parasolid, so I will directly go to the Adams. So this is my Adams window. So you can create new database. Already I have created this new database. So directly I will import my CAD model. So go to import. So here choose the parasolid option, file type. Then from file to read, right click and click on browse. So go to the folder where you have saved your model. So I have saved here in scissor lift folder. So I will copy that. So and here model name, model guess, here lift table, automatically it will come the initially the name which you have given. So then click OK. So fit the screen, so you can see the model is imported. So slightly this our coordinate system is quite far from our CAD model. We can shift here. So setting, go to the working grid. Here set a location, pick, you can choose your desired location. Okay, so it does not matter that much, it's okay. So here go to the bodies. You can see there are many number of parts. So there are some parts which are not necessary in this simulation. So we can see these pins or some nut bolts, fastener. These we don't need in our simulation, so we can delete those parts. So here all these parts name like socket, head cap, we can eliminate directly. So I will select up to this. So you can see here all the fasteners or some pins are selected. So after selection, right click and simply delete. So our part count is reduced now. So here main task is to first apply the material property to each part, and also we can merge number of parts into single parts. So which are the parts which are not going to move, we can merge into single part. So here we will explore each part one by one. So this is the pin, so we will delete this part also. Now this is a piston, so we will rename it piston. Then this is a cylinder, just simply click here, so it will appear cylinder, or simply you can right click on that part and click on rename. So now this is the pivot point for this cylinder, it will rotate about this point, so we'll give name as a cylinder pivot. Okay. This pivot will be fixed to this base. Then next part is the part which is to which the piston is attached. So we'll give some name as a, let's say, cross member. Now this part is okay. So this part is we can merge with this upper table, so we'll merge with these parts with the table. So let's keep as it is right now. Again this part also with the can be merged with the table, this part also, this part also. Okay, this part also can be merged as it is fixed with the table, this part also. Now this is the main platform. So this is a platform. So if we click here, so you can see there is no mass to this part, so we have to apply the material property. So from user input to choose geometry and material type, click right click here, from gas we'll go select the steel, so apply. Now similarly other parts we can apply the material geometry. Again right click steel, we'll copy this, control C, okay. Similarly here paste it, okay. For each geometry we will apply steel material. So once you apply the material, you can see here it creates the center of mass, and on the center of mass point one marker is created. That means your material is applied to that part. Cross member also, all the parts will apply the steel material only. If you want to check the mass, what is the mass, so just click on show calculated inertia. We will come to see this mass is the 2 kg around. Then okay, these parts will be merged here. First we will rename the parts, these parts will keep it as it is. Now this part is attached with this link, you can see here. So it is going to slide inside this guide, so we give name as a some upper slider, we can see left side. So I will minimize this, upper slider left. Again apply material to this part, control V, still apply, okay. Then next this is also slider, this is going to slide in this guide, so rename it as a upper slide, you can see right. Now change, apply material to this part also, okay. Then this is the link, cross links, so we'll give name, we'll start giving a name from this link. So let's say this is the link, okay. This is the link 1, so I will give name as a L1 material steel. Again you can apply different material also. Then this is link 2, L2, again apply the material, mass properties, geometry and material type is steel, okay. Now this is a links on right side, again right side link, this is a link 3, and this is a link 4 on left sides. So we have not applied material yet, so now steel, again steel, so now on right side links, okay. First okay, this is L5, apply the material, okay. Then L6, okay, this is the L6. Now L7, and finally this is the link number 8, L8. L7 material is not applied yet, apply L8, again paste here, apply. So now we'll change the appearance of each link. So we'll change the color so that we can differentiate between other parts. So to change the appearance color, you have to select the solid, not the part. So select all the solids here of each link. So all links are selected. So right click appearance. So in color tab, just right click here, color. Now go to the guess. So you can choose the color of your choice. So I will check, like, let's say red color, apply. Okay, now I will hide these links right now so that I can work with other model with ease. So here go appearance, visibility off. Okay, so temporary we have hide these parts. So here what will you do, we'll merge these non-moving parts with the table. So here from booleans operation, booleans tab, go to the merge two bodies. So here now right click here, select the part, then second part, right click platform. So continue here. So you can see this is now single part. So similarly do it for other parts also. Take cursor to that part and right click so that it will appear. Right click again. Okay, so here this is also fixed to the table, so we will merge it. So here and here. Okay, and finally this part, select this part, then right click platform. So now we can see in platform there are these many number of solids. So select all the solids, go to appearance, change the color. So I will apply yellow color. Okay, that looks fine. This is a base. Here apply the material, paste it. Okay, so I will change the name as a base. So it will be fixed to the ground. So we will merge these parts to the base. So again go to the merge, little bit zoom it, type a Z for the zoom, T for transfer, and R for rotate. So merge, right click on this part, choose the part. Okay, then second part, right click base. Now continue, these two parts are merged. Okay, second part, here also this part, base. Okay, base again. After merging, it highlights the parts so you can easily understand whether parts are not merged or completely merged. Right click this part and this part. So now our base is ready. We'll change the appearance. Just go to the appearance, color, choose the color of your choice. So we'll apply some dark gray type. Okay, so now this is the lower slider left. will apply material steel, control V. Okay, and this is the right side slider, lower slider right. Again apply the material. Don't forget to apply the material so that it will not give any error while simulating. So I think we have applied material to each part. Yes, so now we'll create the joints. So this cylinder is rotating about this part, this pivot. So I will change the appearance of cylinder and piston also. Cylinder, go to the solid appearance, then right click, gas, let's say green, apply OK. For piston also change the color gas yellow, apply OK. Cross member material is applied OK. Now so we'll create the joints. Now go to the connectors. This base is fixed to the ground, so create fixed joint. First choose the base, just go to the right part and right click here, base, OK, then ground. So as it is fixed joint, you can choose any point for fixation. So I will choose this point. Now this piston is going to rotate about this pivot point, so I will create the rotational joint here. So go to the revolute joint. So first part cylinder, second part cylinder pivot, and location, just right click here. When it is appear at the center, that means it is okay. So it should be along the axis of the this hole. So I will choose this first one. So now you can see the joint is applied properly. This pivot is fixed with this base, so I will fix this pivot to the base. Pivot, second part is the base, okay, and pivot, you can choose any fixation point here. Now this part is fixed, so we choose front view. Now this piston is going to slide inside the cylinder, so we'll create translation joint. So first part piston, second part cylinder, choose the center of mass of cylinder, and its line of action is along the this Z axis of the center of mass marker. Click here, so you can properly see the line of action of joint. This is important line of action of that joint, otherwise it will not move in proper direction. Now these sliders are going to slide inside the glide. So again create translation joint. First part is lower slider, second part is the base. Location, let's say it is at a center of mass, and direction along the Z of that marker. So it is created properly. Yes, it is looks horizontal, then it's okay. Similarly for this slider also, lower slider first part, second part as a base. Location again choose center of mass, direction is along the Z of that marker. For upper slider as well, first part slider, second part platform. Location, slightly rotate it, center of mass, direction Z of that marker. Then again first part slider, second part platform. Location at the center of mass, direction is along the Z of axis of that marker. Now we'll show this on the link. Show. So now all links are appearing right now. So this cross member will be fixed to these links. So create a fixed joint. Right click here. First part is a cross member. Second part is L6 link number 6 location. For fixed point you can choose any location. It doesn't matter. So then similarly here also. First part right click cross member. Second part link 1. Okay, in location here you can choose. Now we will create the joints between these links. So now first we will create the revolute joints here. Right click, choose the link, then right click, second part is a base. Okay, and location should be along the axis. So this is a revolute joint. Similarly, revolute joint here also between two links. First part link number 4, second part link number 1. Choose the location. Either directly you can click here or right click and choose then. Okay, again revolute joint. First part link number 5, second part is the base, location here at the base center. Okay, now again revolute joint will be here. Right click, platform, link number 3 and second part platform. Location will be along the axis of wood. Now again a revolute joint at this location also. Here first part link number 7, second part right click, platform, location, then right click, choose anyone. Okay, now here also between these two links, right click first link, link number 6, right click link number 8 and location, right click. Okay, now this side we have created all joint. Now another side here, first create revolute joints between these links. So again revolute, first part L3, second part I will choose once again connector, revolute joint, first part L3, second part L2, location here. Now these two links, right click L5, right click, again it is appearing L5, so right click L7. Okay, so main part of constraint comes now. So we are not going to create revolute joint here, also at right, sorry, top sliders and connection between links at the center point. Here there will be joint primitives. We will create inline joints. So here we can see create an inline joint primitive. So we choose inline joint. First part is link 1, second part lower slider location. So I will zoom it here. So for location, choose the center point and it should align along the axis. So choose, okay, this joint is created, you can see here joint primitive. Similarly here also, little bit zoom it, again inline joint. First part link number 6, second part lower slider on right side location, right click, or center is not appearing there, again right click, so center is appearing now. Again you can right click here, choose the center, so the joint primitive is created. Now on upper side also, inline joints, first part link 8, second part is slider, now on the opposite side here slightly rotate or zoom in as per your convenience. Inline joint again, first part link number 4, second part slider location, right click, and for direction or axis, okay, these 4 joint inline joints are created. Now here also for piston and cross member, here again go to inline joint, first part piston, second part cross member location, center and axis, choose the center, okay. Now here also where these two links are crossing each other, again go to inline joint, select first part, second, not a base, second should be this link, sorry, this side you can choose L2 and L1 CM, it's okay, two different bodies, okay, we have chosen first L2, then L1, location C, center of mass, yes. Now here also select inline joint, right click link number 4, then second link number 3, L3 center of mass and along the x-axis of marker. So inline joint is created between at the crossing point. Now here also select first body L5 link number 5, second body link number 6, location and axis. Okay, here also repeat the procedure. Now all the joints have been created. So we'll apply motion to this piston. So we have created translation joint between piston and cylinder. So we'll apply some motion to that joint. So go to the motion tab. Here choose translation joint motion. So and select this joint here. It will show as a joint 1. Okay, you can see here arrow, joint arrow. By default it is 10 times of 10 into simulation time. That means if I run the simulation for 1 second, so movement of the joint will be 10 into 1, that is 10 mm. Now go to the simulation and try to run this simulation. By default just try to run. So now it is working. Yes, we have kept by default displacement. Now we'll change this displacement. We apply some step function to the motion, like forward and reverse motion. So regarding a step motion, I already uploaded one video on step function. So I will create step function, step. So independent variable is a time. So when time is 0, displacement of piston is 0. When time is, let's say, 5 seconds, displacement should reach at, let's say, 200 millimeter. While coming back, so again I will add step function. So already I have completed 5 seconds. Now between 5 to 6 seconds it will remain idle. Now when time is 6 seconds, its displacement is 0, and when, let's say, time is 10 seconds, it will come to its original position, let's say minus 200 mm. So we'll verify. Okay, error in function here, step. Okay, here time, I'm missing time. Now it's okay. Verify function syntax is correct. Okay, apply. Okay, then again okay. Now I will run it for 10 seconds. Let's say step number of steps will be 500 and run it. Yes, it is working very nicely, you can see. So 6 seconds, it is coming back to its original position. Okay, we'll go to the post processor or result tab. We'll check the forces on various joints. So previous slides I will clear. Clear plot. Here I will load animation. Here I will choose any joint for constraint. Let's say choose any joint. I will say any element force. It is moving in y direction, so I will choose y direction force. So we can see the force here. Force on joint is decreasing, then it is increasing while coming back. So like you can add some weight here, like you can create one body and you can place on this top platform, and you can check again the force on the same joint, so it will be changing. Now let's say create some box here, so I will delete. So it's okay at any position. So go to top view, move it slightly here, let's say 5 mm. Okay, 20. More distance 40. Okay, front view, let's say slightly will move up. Okay, so either we can define contact here or we can fix this object. Let's say we define some contact between these two contact, high solid tubes or pick. We can right click here, box, and second part is this platform or table. Okay, now we'll run the simulation. Sorry, instead of defining contact, we'll fix this, because there is with some overlapping surfaces. So instead of contact, we'll fix this box part to this table, and we'll increase its weight. Let's say it is now 335, let's say 500. Now again we'll run it. Change reverse motion slightly, we'll make it is a 300. Again let's see how this works. Up to 5 seconds it will move up, it will stop at 5 seconds. You can see here 5 seconds stop. Now 6 seconds it is coming down. Yes, it is overlap, that's why it is failed. We can reduce the motion to 250. Okay, then okay, and again run. That's fine. Again, we'll check the result if we want to see the effect. So initially this force was around 4000 4500. So we'll check, clear the plot. Same joint will take object constraint element force y direction. So you can see the force is increased after placing the weight. Same joint, but magnitude of force is increased. So similar way you can find the forces at different joints, different location, by using different speed of this motion. If I increase the speed of the piston, again the forces are going to increase. So thanks for watching this video. Do like, share and subscribe. Thank you.